Okay, this is another example from your book of a mass to mass stoic problem. Gasohol is a mixture of ethanol and gasoline. Balance the equation and determine the mass of CO2 produced from the combustion of 100 grams of ethanol. So of course the question even tells us the first thing we need to do is balance the equation, because you cannot do stoichiometry without a balanced equation. So if I want to balance this equation, I notice I have 2 carbons here and only 1 carbon here. So I'm going to need a 2. Now when I do that, that gives me 2 times 2, which is 4 oxygens, plus that 1 oxygen. And I have 2 hydrogens. But over here, I have 5 hydrogens, but only 1, and plus that one, so that's 6 hydrogens. So I only have 2 hydrogens over here. So I need to have a 3 there. It gives me 3 times 2, which is 6, and I have 5 plus 1 is 6 hydrogens over here. Now when I do that 3, that gives me 2 times 2, which is 4 oxygens, plus these 3 is a total of 7 oxygens. I have 1 oxygen here, plus these 2. So if I put a 3 here, that gives me 6, plus 1 is 7. So my oxygens are balanced, and I just leave that as a 1. So it is now a balanced chemical equation. And now I'm going to go with what I start with. Always write down what you start with first. 100.0 grams of ethanol, which is C2H5OH. That's what I start with. Alright? And step 1 of stoichiometry is to convert to moles. So, to convert to moles, I have grams of ethanol on the top, so I need grams of ethanol on the bottom. And I'm converting to moles, so I'm going to have moles of ethanol on the top. And since it's a conversion, it's 1 mole of ethanol equals the molar mass of ethanol. Well, ethanol is 2 carbons, 6 hydrogens, and 1 oxygen. So I take the masses of each of those, add them together with however many there are, so 12.001 times 2, 1.008 times 6, 15.999, add all that together, and we get 46.069 is the molar mass of ethanol. Now, that's step 1. Step 2. Step 2 is to set up your mole ratio. And I put the moles of my known substance. Your known substance is what they tell you in the problem. So your known substance is moles of C2H5OH. I know it's moles because it is a mole ratio. I'm looking for moles of CO2 because the question asks to determine the mass of CO2. So CO2 is what I'm looking for. Now, the numbers that go here come from my balanced chemical equation. My coefficient of ethanol is 1. So I write a 1. But my coefficient of carbon dioxide is 2. So I write a 2. Alright? And the final step, step 3 of stoichiometry, is to convert to my final desired unit. I want mass. So my final desired unit is grams of CO2. So far I have canceled out my grams of ethanol. I've canceled out my moles of ethanol. I have moles of ethanol here, so I need to cancel out my moles, of CO2. I need to cancel out my moles of CO2. So I put moles of CO2 on the bottom. And since it's a conversion, it's 1 mole. Notice I had 2 moles here. The only reason I put 2 here is because that's the coefficient. And in the mole ratio, we use our coefficients. Any other time, the number in front of the unit for mole is going to be a 1. And I need the grams of CO2, so I need the molar mass of CO2. Carbon is 12.011, oxygen is 15.999, and there are 2 of them, so I do that twice, and that gives me 44.009. Okay, and again, moles of CO2 have canceled. I'm left with grams of CO2, which is what the question asks for. So now I'm going to multiply across the top, so that gives me 100.0 times 2 times 44.009 divided by what's on the bottom, 46.069. Alright, so I put this in my calculator. I have 100.0 times 2 times 44.009 equals, and then I divide by 46.069, and that equals 191.0568929. But of course that's not what I write down as my answer. Since I started with 4 significant figures here, remember that decimal makes that 0 significant and all the other 0 significant. So I have 4 significant figures. This is a counting number, so its significant figures don't matter. And these are constants, so their significant figures don't matter. So the only number that actually has significant figures is 100.0. So those 4. So I need 1, 2, 3, 4. And so I look at this one, it's a 5, so I round up. So that's 191.1 grams of CO2. And there you go.